Welcome to a tutorial on installing gem5 with Sandia's Structural Simulation Toolkit version 2.2.1. I'm going to start with the assumption that you've already installed SST 2.2.1 and that you're running CentOS version 6.3 64-bit edition. So in the home directory here, I've already got SST, and I'm going to add some packages necessary for gem5 to be installed. Those include scons and zlib and subversion. We're going to be using the subversion to download the XML file from the SST repository. Alright, so after we've got these packages, what we're going to do is make two modifications to the bashrc file. The first is to edit the LD library path. We did that previously with SST, and now here we're going to add in the existence of the x86 simulator. So that's what we're going to be adding here. And how I'm going to edit that system variable is just add it as a command to export it in bashrc. And there's another one called the m5exe variable, and this is telling the SST simulator where to find the binary that we're going to execute. So this would be very near the end of what we're going to be doing, but I'm just going to load these two variables into bashrc before we get started here. Alright, so now if we look at the tail of bashrc, we see that the last couple lines here, this is the LD library path that we had in there previously from the SST installation. We can leave that in there without any harm because we're going to overwrite it with this update, and then we're specifying where the binary is going to be to execute with gem5. Now to load those into our current environment, I'm just going to do source. Alright, now we can get started with SST installation. So I'm going to change into the directory where we previously had SST. So in that directory we've got boost and the SST source code, and now we're going to download gem5. This isn't the gem5 from the ARM website because SST takes a modified version of it. So they branched their source a little while ago and they're using a slightly different version. So what we're going to do is we're going to go into that simulator directory, and there's a bunch of stuff that needs to be made. And before we do that, we're just going to drop in a link here, a soft link. So now we've added in this nicMmu.h file. And then we're going to go into the gem5 directory and build the simulator. So we're going to use scons to do that. It's going to build this lib-gem5 opt. So that'll take a little bit of a while, but eventually what we're going to get back is a simulator for the CPU. Alright, so the scons build of gem5 just finished, so you can look at the elapsed time there to see how long it took. Next up, we're going to provide a soft link to the SST packages folder for gem5. And now we're going to configure SST to realize that gem5 is there. So we have to go back into the SST directory, and then we're going to run autogen, which will view everything that's available basically till they configured what's going to happen. So now once autogen is done, we're going to use configure, and configure has to be explicitly told that SST exists, boost exists, and now gem5 exists. So this is the x86 processor we just built. configure is finished. There's two more steps. They're going to be make all, which is going to take approximately 15 minutes. I'm going to get that started. I'll come back when this is complete. So make all just finished, which means the next command is make install. Make install doesn't take very long, and the next thing that we need to do is to have what's called an sdl.xml file. This is going to contain the description of what program we want to run. It doesn't come with the SST or gem5, so we're going to grab it from svn. I'm going to go into my scratch directory and then check out the SST repository. Now the next thing that we want to do is actually run SST with gem5, and to do that we're going to go in to make a sample application. I have to wait a little bit to have the svn checkout finish. Now if we look in this M5 directory, this M5 is the old name for the gem5 simulator, and we're going to issue make. So make is going to act on this hello C to compile it. So as a result, now we have a binary called hello. If we look at the contents of hello.c, it's got a few extra things, but the things that we care about are hello Mike. At the beginning it's going to print that, and then at the end it's going to present goodbye Mike. So if I run it here in my host system, I can see, besides all the things it spits out, hello Mike and goodbye Mike. So this is just a sample application that we know runs in the host system, doesn't take any command line switches, and then we're going to run it. Use the example.xml file, and so we're going to be in that directory and then run the gem5 binary using, we're going to use the sst binary, and we're going to specify this example.xml as our configuration. So I just ran this and I see initially hello Mike, and then it gives the process ID, and then lastly it says goodbye Mike. And this hack here sentence comes from the gem5 simulator. The reason that we needed to go into this XML directory here is because if we're not in this directory, then the SST binary, which is the thing that we use to call SST, doesn't know where to find XML. The example.xml file. Alright, so what's in the XML file? If we look at example.xml, all we see is the important thing here is that it's pointing to example m5.xml. So I have to chase a little bit further into the rabbit hole. And in this directory, this XML file, this is where the name of the executable is being passed in. It's being passed in as an environment variable, m5.exe, and that's the variable that we set earlier in bashrc. So if we look at the tail of bashrc again, we remind ourselves that bashrc, again this is export m5exe. This is that binary that we just compiled where it lives. So if the m5exe variable is where the binary lives, and that is set in example m5.xml. It's a little bit convoluted, but the main point is that the SST binary finds the example.xml here, and that specifies another example XML at example.m5.xml, which has the binary. So this is how we get a program to run in SST version 2.2.1 with gem5 on CentOS 6.3. Thanks.